One of the big factors that is going to undoubtedly influence the future of mobility is how we address its environmental challenges, because they're going to shape both the types of mobility that we have access to in a given area, say the extent of car use, the extent of airplane use, the extent of trucking, and so on. And environmental considerations will also shape the nature of those things. It will change how our vehicles are. Going back and thinking historically, the vehicles we buy today, new vehicles, are far cleaner than the ones that I had growing up. Like my very first car had no catalytic converter on it, no pollution controls. And as we go forward and factor in some of these environmental challenges in mobility, they are inevitably going to shape the kinds of mobility systems we have in the future. And that's why it's really important to develop a good understanding of the environmental aspects of mobility in particular, because it really will influence the nature of mobility in the future. Like many other human activities, mobility touches the environment in many ways. For example, when I get into the introduction in the course, I have a photo that I took out near my house of a deer trail. Animals are mobile by nature, and the very process of moving around, like deer going back and forth over the same path over and over again, makes what is for them a road, a deer trail, that impacts the environment, tramples vegetation. And when we humans travel at a much larger scale, the many millions of us on the road and so on, we of course have the roads, we have the cars, we have airplanes, we have trucks to deliver us goods, trucks and trains to deliver raw materials to factories that make the goods. All of these things impact the environment in some way. We ask the question, well, which impacts are the most significant in terms of their environmental effects and, as we might say, their ecological costs? In that case, the two most impactful ones are air pollution, meaning the kind of air pollution that causes smog and can aggravate asthma and other respiratory ailments. That what we call conventional air pollutants or criteria air pollutants. The other big area is global warming, the emissions associated with burning fossil fuels that are creating a CO2 buildup in the atmosphere that is disrupting the Earth's climate. We don't have laws on the books in most places that require it to be considered. A few jurisdictions do it. In the United States, for example, California has had a law on the books requiring that planning consider global warming impacts. But in most states, and by and large for the United States at large, it's not really factored in. Mobility is really part of life. And I'm an engineer by training, but I've been doing public policy work for the last half of my career. And what I've learned, one of the things I've certainly learned over that period is that when you do your engineering, as an engineer by training, you're very quantitative and you're trained to break a problem down into analytic pieces and work through, and you can get a great solution on paper or on a computer. But then when the time comes to translate that into the real world of everyday life, including the real world of everyday mobility, what we work out in an idealized fashion in engineering isn't always necessarily going to translate. It's not necessarily going to work right the first time. And that's why we really need to take an interdisciplinary look at mobility challenges. In my case, I teach the module on mobility and the environment, and that is truly an interdisciplinary challenge. Engineering is a part of it, but you also need to understand ecology. You need to actually appreciate a bit of history. Some political science can be helpful. Public policy studies, economics factors in, because there's a costs and trade-offs to all of this. So to really tackle these problems definitely takes an approach that draws on the wisdom and expertise of multiple areas of study.